All right, so 10.4. Number 1, square root 75. Minus square root of 147. Okay. So the story for square roots. Is anybody have you seen it already? I can't remember what we did, to tell you the truth. Did we talk about how you simplify square roots? You break them down. 2 for 1. Yeah, that's right. We did, huh? We talked about that, right? So let's do that. Let's take that 75. Use your calculator. Some of these numbers are big. So you know what goes into 75, right? 3/4. I'll just think money. Money numbers. We all deal with money. Kind of easier that way. So 3/4, 3 times. Just divide. Just take your calculator. 75 divided by 3. It'll tell you 25. So 3 times 25. To break down the 25, 5 times 5. So that means the 75 is 3 times 5 times 5. So far, so good? So I just broke down the 75. Have we done this before like this?
Yeah.
Yeah, we break down the pieces. And then, and there's nothing in the hook. Nothing's in the hook, which means really what numbers there? 2. That's why we call it a square root. Because it means 2. 2 is squared, right? We call x to the second power, we call that x squared, right? 2 means square. What's the word for 3 in math? Cube is 3. So anyway, let's say square root, which means it's a what? Did I say 2 for 1 deal?
Yeah.
A target? Okay, so yeah, so that's what you do. Because it's 2, it's a 2 root. So that means you're looking for things in groups of 2. So 2 5s in, ships 1 5 out, and they're both gone. So 1 5 to the outside, and the 3 has to just stay inside, because you got to have 2 of them to come out, right, with a square root. So far, so good. And now let's go do the 147. What goes into that? I think 3 does. Doesn't it? Yeah, 3 does. So divide by 3, what's that? 49. Oh, good. Okay, and then 7 times 7. So the square root of 147 is 377. So there it is again. 2 7s in, 1 7 out. So that one's 7 root 3. So I just simplified both those. And it breaks down to 5 root 3 minus 7 root 3. And so now you can just subtract them, huh? Dealing with roots is just like dealing with like terms. Like if it was an x. You guys know how to do that, right? What if you had 5x minus 7x? What would that be? It'd just be minus 2x, huh? Remember like terms? With letters? Well, that's exactly how roots are. Just pretend they're a letter, and you'll know all the rules just fine. It's just like if that was a letter. So 5 roots of 3 minus 7 roots of 3 is negative 2 root of 3. And that's it. Is that good on that one? We okay? Questions I can answer? It's all good. Okay, please speak up. You can try that one. Same thing. So you got to use your calculator. Break down the 48, break down the 32, break down the 27, do the 2 for 1, ship out. Notice there's already numbers out front, huh? So anything that comes out and hits those numbers, we'll just multiply them when it comes out. Because they're multiplying inside, so they'll multiply outside. Same thing. 8, that's 6 times 8, or however you want to do it. 2 times 3, 2 times 4, 2 times 2. Okay, so that's 2. Square root of, it's going to be 3 with 4 2's. You get the 48 okay? 48 breaks down to be 1 3 and 4 2's. And so then we'll do the 2 for 1 ship out thing. So 2 2's in, ships 1 2 out, and they're gone. Another 2 2's in, ships 1 2 out, and they're gone. So what comes to the outside there is 2 times 2 times 2, 8, with the 3 left inside. Good so far? Good for the first one? Now break down the 32 and the 27, same thing. So the 32, 4 times 8. And the 4, 2 times 2, the 8, 2 times 4, the other 4, 2 times 2. We good there? So then, what do we have? Minus 3, and then, so we really have 5 2's in there, don't we? 32 is 5 2's.
Isn't it 6?
I think it's 5.
Oh, yeah.
I think good. 1, 2, 3, 4, 5 of them. Okay, and then we ship them out, huh? 2 2's in, 1 2 out. 2 2's in, 1 2 out. They're gone. They multiply on the outside. 3 times 4 is 12, root 2. So they multiply that 3 that's already out there, huh? So the 2 2's come out. 2 times 2 is 4 times 3, 12. And that one extra 2 has to stay in because there weren't 2 of them. We good with that? This 2 right here just stays in. Making sense what we're doing there? So it's 2 for 1. Whenever you have 2 of anything inside, it ships 1 out, and then those 2 are gone. Okay, and then finally the 27. Break it down. 3 times 9. It's 3 times 3. So that's 27 is 3 3's. Again, it's 2 for 1. So 2 3's in, 1 3 out. So it's plus 3 root 3. Good. So we got them all simplified now. Did all the 2 for 1 shipping out stuff. Now, how can we simplify these? What do we do to simplify those? Do you notice that, you know what it's like? See how the first one and the back one are both root 3's? So those are going to be the like terms. So in other words, this is like, it's kind of like 8x minus 12y. He's different roots, so he's like a different letter, plus 3x. That's what it's like. So you know, what would you do if you had 8x minus 12y plus 3x? Yeah, the x ones would combine and the other one would just stay different. That's exactly what you do with the roots. They're just like letters. So different roots are like different letters. Just exactly right. So 8 root of 3 plus 3 root of 3. That's going to make 11 root of 3. And the minus 12 root 2, that just stays as it is. And we're done right there. Can you read that? Sorry, getting a little scribbly there. Let me rewrite that. So again, the 8 and the 3 is 11 root 3 minus 12 root 2. And so we're done with that. Is that good? It's all making sense? Questions I can answer on this one? What's that? Yeah, this is the answer just like this? Yeah. Yep. That's it. As far as we can go. Yeah, we can't do any more because those are unlike roots. Unlike. So that's as good as it gets. Yeah. Exactly. All right. Okay. Yeah, so, yeah, this has got a couple tricks to it. The, when you got a root that's over a whole fraction, see how that first one is over the entire fraction? Right there, not just the top part or just about this whole thing. So that means you can just put that root on the top and on the bottom separately. I think that's helpful. So you can just do it that way. So top and bottom. So whereas the one in the right, the root is only on the top part, isn't it? It's not on the bottom, right? So, okay. So now, what do we do with the cube root of 64 right there? Yeah, simplify it, right? Try breaking it down. There's stuff in there, huh? So whenever you have stuff inside, go ahead and break that down. So that's going to be 8 times 8 or, 2 times 3, whatever you want, just a million ways to break it down. Keep going. 2 times 4, 2 times 4, and each of those 4s is 2 times 2. So, so that cube root thing, so we have the cube root, and the 64 is 1, 2, 3, 4, 5, 6 2's, isn't it? You with me? 1, 2, 3, 4, 5, 6 2's. So that denominator, that cube root of 64, is the cube root of 6 2's multiplied together when you break it all down. Now, what is it with a 3 in the hook? What's the deal at target? It's not a 2 for 1 deal. It's even better. It's a 3 for 1 deal, right? So whatever's in the hook is the deal, right? There's a 3 in the hook. It's 3 1. 3 for 1. So if you're at Target and things are on sale, 3 for 1. So that'd be 3 2's in, 1 2 out, and they're gone. And then another 3 2's in, 1 2 out, they're gone. And they multiply on the outside. So that's just going to be 4, isn't it? That whole cube root of 64 is just 4. 2 times 2. 1 2 from the first group of 3 2's, 3 for 1, and another 2 from the second group. And 2, and then the root vanishes. Why? Because there's nothing left over in the root, huh? Like the last couple of times, we always had like another number that couldn't come out, so then the root has to stay because there's something inside of it still. But here, everything left the root, didn't it? There's nothing more in there. So the root just vanishes. There's nothing inside the root. Can't have the root anymore. So the root is totally gone in the denominator, and we just have 2 times 2, 4. So that denominator, let me just bring it over here. So this problem becomes cube root of 5 over 4 minus cube root of 5 over 5. So that cube root 64 just became 4. Okay so far? Okay, so now we're pretty much done with the root work, and now we just need to subtract those. How do you subtract those two fractions?
LCD.
Common denominator, yeah. Gotta make the bottoms the same, huh? What can we make both those bottoms become? 20, huh? Just multiply top line. This is just normal. It's not easy, but it's normal common denominator stuff, yeah. So just come in there and go, okay, top and bottom of this one by 5. Top and bottom of this one by 4, right? Top and bottom, make them both 20. So that'll be what? 5 cube root of 5 over 20 minus 4 cube root of 5 over 20. That good? Common denominator. So now we can just make them one fraction. You don't need 2 anymore. They're the same denominator. And so we have 5 cube roots of 3. Remember roots? When you add, subtract them, it's like x's and y's. Are these the same exact root? They are, so it's just like the same letter. So same roots are like same letters, different roots are like different letters. So this is like a 5x minus a 4x kind of thing. So it's just 1x or x. So it's just going to be 1 cube root of 5. You don't really need the 1, but I'm just doing it to show you what happened. So 5 cube roots of 5 minus 4 cube roots of 5 left 1. Cube root of 5, and again, you don't need the 1. We're done. How we doing? Is that good? Questions I can answer?
Why is it that before, for the problem before, it was a -3, but we only took out 2?
Oh, because that was a 2 in the hook.
Yes.
Yeah, let's go back. So, which one are you looking at? Which?
Number 2.
Yeah, number 2. The left, middle, or right.
Yes, for like the number 3.
This?
Yes.
Okay, that 3 was already out from the beginning.
Okay.
Oh yeah, I see. That's not in the hook. Great question. Yeah, see, this is a big 3, not a little tiny 3 in the hook.
Okay, now I understand.
Really good question. I didn't think about that. Good. Thanks for bringing that up. Yeah, right. So there's a difference between, like on this last problem, number 2. These big old numbers, those are not hook numbers. They're just multiplying. And so there's nothing in the hook, which really means there's an invisible 2. Yeah, good question. Whereas at number 3, if we go back to number 3 here, see that's a tiny little 3? Oh, of course, I didn't make the other one so tiny, but I should have. This one's supposed to be a tiny little 3 also. Yeah, those are both in the hook. They're, what do they call it? Index. They're both the index of the root. So they're making it a 3-for-1 deal. They're not a number that's sitting in front to multiply. Whereas in number 2, those guys were numbers just sitting in front. There was a visible 2 in the book. Good question. Thank you. Other questions on that one? Good. That was helpful to us all. Okay. That's a big one. Okay, so like that 5 in the front of the first one, that's not in the hook, huh? That's just a big 5 multiplying. What's in the hook of all these guys then? 2. There's a visible 2 in the hook. These are all square roots. So these are all 2-for-1 deals, aren't they? That makes sense? Okay. So if you go to Target, we'll do the, there's already, I was in, what was I in? I was in Home Depot and Lowe's this weekend because my stinking sprinkler system has suddenly broken. I spent the whole weekend digging in the dirt in my front yard. Anyway, so I was at Home Depot and Lowe's, and so they already had their Christmas stuff out. I'm like, man, it's not even Halloween. They're going earlier every year. Pretty soon it'll be right after 4th of July, huh? Anyway, so I'm sure Target, I didn't go to Target, but I'm sure they have their stuff out too. So it's 2-for-1 deal. So what if you go to Target or wherever and it's a 2-for-1 deal and they have 11 A's, right? That's what A to the 11th is. 11 of them, 5, 6, 7, 8, 9, 10, 11. So we got 11 A's on sale, 2-for-1. How many are you going to pay for? So every two. So how many are going to come out? 5 of them, huh? Yeah, so the easy way to deal with letters like that with the big powers on them is just to make them even, and if they were odd, that's an extra one. Am I making any sense? So in other words, what I'm suggesting is, hey, let's just go back and go, look, A to the 11th, that's A to the 10th with 1 extra, and B to the 7th, that's B to the 6th with 1 extra, huh? Now, why is that a good way? Because then when you make it even, you can just cut that in half, right? The even, we can just cut in half. 10 items on sale, 2-for-1, you're going to pay for 5, huh? 6 B's on sale, 2-for-1, you're going to pay for 3 B's. So out will come 5 A's, out will come 3 B's. This makes it easy to see. So if they're odd powers, just make them even with 1 more. And then cut the even in half. That's an easy way to do the 2-for-1 thing. Right? So the A to the 10th, out will come A to the 5th. Because right, you're going to pay for 5 of them to buy 10 on 2-for-1 sale. And B to the 6th, 6 items, 2-for-1, you're going to pay for 3. What's left inside? A, B. We good? Now next, can you do the same thing for the one in the middle? So these are both odd powers, huh? And they made them all odd powers, didn't they? So make it even with 1 extra, and then cut the even in half. Now notice there's already an A, B in the front of that one. So that's going to be extra when it comes out front, right? So does Target really have Christmas stuff out? Oh, because they sell Halloween stuff, right? So they probably want to. They don't want to mix those holidays. That might be strange, kind of a scary Santa thing. So whereas Home Depot and Lowe's, I don't think they get a lot of Halloween business. So they're just diving into Christmas. Okay, so the AB stays out there, and the A to the 9th, that's A to the 8th with an extra A. So that's what I'm saying, with odd powers, make it even with 1 more. You can do it all in your head if you want. You don't have to write all this out if you don't want to take the extra step. Does everybody see what I'm doing there? So odd powers make it even with 1 more. So A to the 9th is A to the 8th with an extra A. B to the 5th is B to the 4th with an extra B. And then cut them in half. Send them out. Cut them in half. Send them out. So we say, okay, A to the 8th, out comes A to the 4th. B to the 4th, out comes B squared. So what do we got here? Minus. Now, so that A to the 4th and B squared. Oh, the plane 4. What's the square root of 4? Yeah, that's going to just ship out a plain old 2, huh? We good there? So we get 2, and what is a to the 4th and another a? It's going to be a to the 5th, huh? And b squared and another b to the 3rd. What's left inside? An extra a and a b. Kind of a mess. You okay with that one? Does that make sense there? Did you do that third one? So that b to the 7th, we're just going to make that b to the 6th and another b, huh? We good there? And what are we going to do with that b to the 6th? Just cut it in half, huh? Just cut it in half and ship it out. So b to the 6th, cut it in half. Out will come... Oh, and the root of 36, that's 6. So out we got a to the 5th, and out will come b to the 3rd, because that's half of the b to the 6th. What's left inside? This a and this b, huh? Root of ab. Did you track with that one? That one okay? Not making sense? See what's happening there? So, so again, odd powers like b to the 7th. I just make it even with one more and then cut the even in half because it's 2 for 1 deal. So out comes b to the 3rd, and the extra a and b are left inside. So now we're down to this level. So we've got the roots simplified. Now, are these? They all have letters. Are the letter patterns the same? Exactly the same? Yeah, they're all a. Every part of them is the letter pattern is the same. They're all a to the 5th, b to the 3rd, root of ab. A to the 5th, b to the 3rd, root of ab. A to the 5th, b to the 3rd, root of ab. Yeah, they're all big old like terms, aren't they? So it's 5 of those things minus 2 of those things plus 6 of those things. So 5 minus 2 is 3. Add 6. It's 9 of those things, of those a to the 5th, b to the 3rd, root of ab things. There we go. Done. You just add the numbers in the front. Add and subtract the numbers in the front. It's just like terms. That's how we always add and subtract letters, huh?
I got lost on that last part where it says 6, a to the 5th.
Yeah.
How'd you get the 5th power on that one?
Oh, the a to the 5th was already in the front from the very beginning. Yeah, it was just sitting out there right from the beginning. Yeah, don't forget about stuff that's already out front. We get so focused on the inside stuff. Yeah, the a to the 5th was right at the beginning already there. Other questions on that one? That making sense? Questions? So it's a little tedious, but it's just cut for powers. You're just cutting them in half, basically. That's what a 2 for 1 deal does for roots and at target. Okay, so big numbers. So notice we have 3s are in the hook, aren't they? These are all cube rooters, aren't they? So they're all going to be a 3 for 1 deal. So go ahead and just use calculator. Those are big old numbers. Just use your calculator, break those things down, and then do a 3 for 1 ship out. When it comes to the letters, we have y cubed, so 3 y's in, 1 y out. Right? So just break them all the way down. Give you a sec. All right, so what times what? 256. If you divide by 2, that's 128. And then 264, 8 times 8. It's just going to be a bunch of 2s, isn't it? Yeah, look at all this. So 1, 2, don't miss any. 3, 4, 5, 6, 7, 8 2s. I got 8 2s. So this is going to be the cube root of 2, 3, 4, 5, 6, 7, 8 2's x and y cubed. And then you gotta, so what's that gonna do? It's a 3 in the hook. I'll let you take care of that. So 3 2's in, 1 2 out. 3 2's in, 1 2 out. So 2 times 2 is 4 on the outside. Oh, and then the y's, huh? Y cubed in, 1 y out, because it's 3 in, 1 out. 3 for 1, right? So 4y on the outside, 2 times y. 4y on the outside there. So kind of running out of room on that one. It's going to be, I'll come over here. It's going to be, well, it'd be best if I could, yeah, I just made it too big there. Here, let me do this, get this out of the way. So in the end, we're going to have 4y cube root of, what's left inside? 2 times 2 is 4x. 4y cube root of 4x? Is that good? For the first one, is that making sense? Try the middle one at the back. Lots of numbers. So when I got numbers like they end with 0 or 2 zeros, that's just 10 or 100, huh? So I'm just going to go 5 times 100. Rather than like 2 times 250, that'd probably take longer. If you have numbers that end with zeros, just do 10 or 100 or whatever. And then 100 is 10 times 10. And so that's 2525. Okay. So then, putting it all together, what do we have? We have 8 cube root of, what, 2 2's and 3 5's, huh? 1, 2, 3 5's and 2 2's. X, y cubed. Is that good? It's just tedious, isn't it? Just breaking all these little numbers down. And then the 3 5's inside. 3 5's in, sends 1 5 out, and the 3 y's in also sends a y out. So we get 40y cube root of what? 4x. I'll bring it down here. Plus 40y cube root of 4x. Everybody see how I got that middle one? Good. The 8 was already out there. And then the 3 5's in, sent a 5 out. 5 times 8 is 40. 3 y's in, sent 1 out. It's a 3 for 1 deal. Finally, the 108. Okay. Let's do the 108. Break it down. 2 times what? 54. 6 times 9. 2 times 3, 3 times 3. So what do we have there? Y on the outside, cube root of, what's on the inside? 1, 2 2's, 3 3's, and an x. So I break it all down. So, and then it's a 3 for 1 deal, so 3 x's in, 3 3's in, sends 1 3 out. So here, I'll bring it down here, plus 3y cube root, what's left inside? 2 times 2, 4x. Right? So all of them seem to be leaving 2 2's inside, don't they? And why can't those 2's come out? Because it's a 3 for 1 deal. This is a cube rooter. You got to have 3 2's to ship out. Otherwise, 2 2's just have to stay in and they remultiply to be 4. Okay? We're all the way down to there. We can kind of guess it after a couple of these, right? It's going to be a y cubed root of 4x. So they're like terms again, aren't they? All the letter patterns match. I'm not sure they'll always do this. No, we had one earlier where two of them were alike and one was different, huh? So they won't always do this, but often. So they're all y cubed root of 4x, y cubed root of 4x, y cubed root of 4x. So that's 4 of them, and 40 of them. That's 44, and 3 more. 47 of them, right? So the answer is going to be 47 y cubed root of x's. Just add them like terms. 47 y cubed root of x. Y cubed root of 4x. Oh, I forgot the 4, didn't I? Let me get that straight. That's part of the deal there. There we go. So 47y cubed, that cube is, it's not on y, it's in the hook. Here, let me try messing it all up. So, there we go. 47y cubed root of 4x.
And we don't do powers on them because it's 3 y's.
Which y's are 3 y's?
For like the 47.
Right.
Y.
Oh, don't make it y cubed? Yeah, because think about adding. What if you're, it's because we're adding, not multiplying.
Okay.
So if you're adding y plus y plus y, that'd be 1y, 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 be 3 in the front. When you're multiplying letters, that's when you add the powers. Yeah, good question. So it's because we're adding these guys that we just add the numbers in the front. We don't make the y's y cubed or anything. That'd be multiplying. That's when you multiply letters that you do the powers. When you add letters, you just add the numbers in the front. Good? Other questions on that one? Okay, those take a long time, don't they? They're real. So break them all down. Like I said, the one on the left, you're going to have a root in the top and a root in the bottom. Whereas the one on the right just has it in the top. So we go from there. Like that, right? So break down that cube root of 16 and the 27, right? Just break them down. I'll just take it over here maybe. 16 is 4 times 4, which is 2, 2, 2, 2. So 4 2s, and the 27 is 3 times 9, 3, 3. And then the 54, I'll just do them all over here on the side. 54, 6 times 9, 2, 3, 9 is 3, 3. So there we go. There's all the pieces for those guys. So this becomes cube root 16 is 4 2s. 27 is 3 3s. 54 is what? It's that stuff. A single 2 and 3 3s. Like that. Break them all down to their pieces. 3 for 1. Am I just racing ahead of you here? So keep going. So they're all broken down now. So 3 2s inside sends 1 2 outside. 3 3s inside sends 1 3 out. And hey, on the bottom, there's nothing left in the root, so the whole root will vanish, huh? On that bottom, there'll be no more root, it'll just be 3. Whole number 3, when there's nothing left in the root, it vanishes. So, and then here, 3 3s sends 1 3 out, and they're gone. Okay, so what do we have here? 2 cube root 2 over just 3 minus 3 cube root 2 over 6, huh? Yeah, that good? Good to there? Everybody see what happened? Did you guys track with that to there? We okay? So these 3 3s in sent this 1 3 out. That good? So now, how do we, what do we do? Two fractions, you want to subtract them, what do you got to get? Common denominator, huh? So I'm not going to reduce this right now, because I need to make common denominator first so I can subtract them, huh? So multiply top and bottom of this guy by 2. So we can combine them. So multiply top and bottom by 2. Let me get rid of this stuff here. And what do we got? So we've got 2 times 2, that would be 4. Cube root 2 over 6 minus 3 cube root 2 over 6. 4 cube roots of 2 over 6 minus 3 cube roots of 2 over 6 is 1 cube root of 2 over 6. So you don't even need the 1, huh? We're done. That 1's not needed. Think I can answer on that one? Any questions at all? Don't be shy. Ask questions if you haven't. I was watching. I had to evaluate one of my colleagues. We do that for each other, and I was watching him teach. He's a really good teacher. And I was noticing those. It gave me a chance just to sit back and watch a class happen. I was noticing the students weren't, that there was a couple really hard things he was doing, and I was sure that they must have some questions. And he was like me. He was like, so questions? Anyway, I thought if they would ask, probably, it'd be more helpful. So anything I can answer? Is that good? Yeah.
How'd you get from on the top right there where it says 354, square root 54?
Yeah, so what did I do? Oh, okay, yeah, the 54 broke down to these guys. When I did it on the side, I erased it now. But when I broke down the 54, it came down to be that stuff. So I took that little 54 and I said 6 times 9, 2 times 3, 3 times 3. Yes, I broke it down. It was that, it was all this stuff here with, that's the guts of a 54. A single 2, 3 3s. Yeah, good. So it came to that. Is that good? Other questions I can answer? Y'all seen how that all happened? Is that good? All right. So I'm multiplying root 11 times root 2 plus root 3. Root 11 times root 2 plus root 3. Okay, so how do you multiply? Well, you just multiply. There's nothing too amazing. Just boom and boom. So that'll be root of 22 plus root of 33. Yeah, that's it. Nothing more there on that one. 13 will have a little more to it, but that's it for that one. Good so far? So there's number 12. Let's go to 13. I'm going to rewrite 13. We need a little more space. So 13. Yeah, good question. Because they're not like roots. Yeah, really good question. You can't, you can't add them because you know what it's like? It's like x plus y. Yeah, different roots are like different letters. So whereas if we had something like, if we had like 3 root 22 plus 5 root 22, they're both root 22s, then I could add them to be 8 root 22s. Is that making sense? But if they're different roots, like root 22, root 33, they're just like different letters. There's nothing we can do. So notice you can multiply different roots, but you can't add them. And that's the same thing with letters. Think about letters. You can multiply x times y, just xy, no big deal. Or you can multiply, 3x times 2y, it's just 6xy, no big deal. But you can't add 3x and 2y, You just say not like terms. Well, it's the same thing for roots. You can only add like terms. Whereas multiplying, you can do anything. That's why, remember, I'm always saying adding, subtracting has all the picky rules. We see it here too. Adding, subtracting is all picky. It's like, no, I'm not going to add unless these are like. Whereas multiply, just do it. Nobody cares whether they're like or not like. And that's true for letters. Exactly the same thing is true for roots. You can't add roots unless they match. They've got to be like. But I multiplied different roots, didn't I? Because it doesn't matter if we're multiplying, you know. So that's just all the way through algebra. Anything can be multiplied or divided, but adding, subtracting is always picky. It's got to be, you know, like, same like letters, or same like roots, or with fractions, common denominators only, right? It's always picky for adding, subtracting. Good. Other questions? That makes sense? Okay, how about 13, root 6y, root 6 minus root y? Okay, now as we move into this one, let me remind you something that will make the problem really easy if you remember. So what if I had like 2 7s in a root? Nothing in the hook, so what does that mean is really in the hook there? Yeah, there's really a 2. It's a square root. And I know there's no 7s there. I'm just making up a problem to give you an idea. So if you had 2 7s in a root, what would that end up equaling? 49. Sure. Yeah, you could say root 49, but can't we go 2 in? Oh, yeah. 1. Now, you're right, though. Root 49, which is plain. Yeah, you could make it root 49, which is also plain 7 in the end, isn't it? So it's even quicker to just ship them out right away. What if you had like 2 11s in a root? What's it going to be? Plain 11, right? 2 in, 1 out. So whenever you get 2 of the same thing in a root, out 1 comes. The root's gone. Right? 2 root 11s make a plain 11. And it doesn't matter if they're separate. Like, I mean, what if instead they were like sitting separate? Timesed. Whatever, same thing. I mean, that's 2 of them, 2 in, 1 out, plain 11, done. Right? You with me? So if you have 2 of the same roots, root 11, that's a plain 11 because that's 2 in, 1 out, isn't it? So with that in mind, as we come up here and multiply, look what's going to happen on that first one. So this guy, you know, it's going to distribute. So first off, it goes there. So you're going to get the root of 6y times 6. And the second one, it's going to go there. And you're going to get 6y times y, right? Good so far? And now, what are we going to do? Start sending stuff out, huh? Yeah. So we got 2 6s in. That's 1 6 out. These 2 together send 1 6 out. These 2 together send 1y out. Is that good? Right? So the 2 y's in, send 1y out. The other 6 has to stay in. And over here, 2 6s in, 1 6 out. The other y has to stay in. Now, can I do more? Can I subtract these guys? Remember, adding, subtracting is picky in every situation. Fractions, letters, roots, always picky. You can only add and subtract if they're completely like terms, meaning same letters, same roots. Not even close. They have different roots, different letters in the front. No way. We're just done right there. That's as far as it can go. Does that make sense? Questions on that one? Like that? Okay, so it's 2 for 1. Okay, so we want to multiply these. So let's see, we're going to FOIL. Remember FOIL? First to both, second to both. On that kind of thing. So here we go. So this guy first, he's going to go to both of those 2. So cube root of A times cube root of A. So when 2 roots multiply each other, the inside stuff multiplies the inside stuff. And the outside stuff stays outside. Am I making any sense? I always remember, I haven't told. So as this goes, so this guy's going there. So these 2 A's are insiders. So they will multiply. Insiders interact with insiders, right? Outsiders with outsiders. So this is cube root of A squared. Good so far. The A's multiply inside, right? Insiders with insiders. A times A squared, just like normal. Okay, but now when the cube root of A goes over here to the 7, that 7's an outsider. He's not in the prison. He's an outsider. So he'll stay in the front, and the A will stay in. They will not make 7A, because they're in different worlds, right? Outsider, insider. Tracking with me? So he's done. He went to both. And now This guy's going to go to both. The 2 will stay outside. He's an outsider. He won't go in and multiply the A. And then 2 times 7, 14. They're both outsiders. So outsiders stay outside, insiders stay inside. So far, so good. Can we do more now?
We can add the square root, right?
What's that?
We can add those, so we.
These 2 in the middle? Exactly. Those are like terms, aren't they? Those 2 in the middle have the same exact letter pattern, don't they? That's cube root of A, cube root of A. Same exact letter. So remember, adding, subtracting is all picky. We can't do any of this unless they match, right? Adding, subtracting is picky, but these match. So we can do 7 and 2, 9. 9 of those cube root of A things, huh? And then the other parts, just bring them down. This is, whoops, I'm making the 3's a little big here. That's cube root A squared, the 14, just bring it down. We're done. There's really nothing more we can do. None of those can be added because they're all unlike terms, aren't they? Right? Adding's a little picky. It's got to be exactly the same. So that's it, as far as we can go. And we can't ship these A's out. Why can't I ship these A's out? Why don't I go 2 A's in, 1 A out? It's a 3 for 1 deal, huh? So those 2 have to stay. Is that good? All is well? All right. I will move number 15 here. Let me write a little bigger. Square root of 10. Square root of 10 plus x root 30. Okay. So that, what's in the hook on these? Yeah, nothing 2, so 2. All right, so give that a try. Remember then when you have 2 of the same thing, so like what's going to happen right here with root 10 times root 10? Plane 10, huh? Because that's 2 10s in, ships 1 10 out. So go ahead, distribute that. So this guy's going to go to these 2. Boom, boom. So square root of 10, plane 10. Yeah. Is that okay? I can do that slower if you want. You can just go straight to 10. You could go like this, 10 times 10, 100. Or you can make it 100. And what's the square root of 100? Plane 10, huh? However you want to see it, it's going to end up a plane 10, isn't it? Lots of ways to see that. Plus... Okay, now what's going to happen when the root 10 goes to the x root 30? Who's the 10 going to multiply? Insiders with insiders. People in the prison interact with people in the prison. Insiders with insiders. So that's going to make 300 in there, huh? Good. And then what do you do with the square root of 300? That's 3 times 100. 100 is 10 times 10. By the way, you might wonder... Hey, why don't you break down those 10s? I don't know if that's in anybody's mind. That'd be a good question. Right, because 10 can be 2 times 5. Why aren't I showing 2, 5, or why didn't I show over here? Well, because as soon as I see 2, a matching pair, I might as well ship out right then. Why go further? I only go further if I haven't found a pair yet. But if I've already got a matching pair, 2 for 1, let's don't do any more work than we have to. Just ship them out right then. So I've got 2 10s inside, 1 10 outside, huh? So it's going to be plane 10 plus 10x. What's left inside?
3.
Just the 3, huh? Just that 3 there. And that's as far as we go. We can't add those, can we? Because adding's really picky. It's got to be same letters, same roots, and it's not even close. So we're just done. Oh, and you can't make 20. You can't go 10 and 10 is 20. Because, again, they can't be added. They're not. That was 10 x root 3 and 10 x root 3. Yeah, then that would be 20 x root 3. But they're unlike. Is that okay? So whenever that 300 just broke it down. As soon as I see 2 10s, just ship 1 in. Okay. Okay. So try that. So as you go, remember, outside numbers multiply outside numbers, and insiders with insiders. first to both. Second to both. First to both, second to both. So this guy's going to go to this guy and that guy, huh? So as they go, insiders with insiders, outsiders with outsiders. So let me do the first one with you. So root 6 times 3 root 6. Can anybody just jump right to the answer for that? What is root 6 times 3 root 6?
18.
It's just 18. Do you see that? And you don't have to go that fast. You want to take it more slowly. The sixes will multiply inside, won't they? Because insiders with insiders. Right? That 3 stays on the outside, and the 2 6s go in the and then, now, could you make that 36? You could. But I'm thinking, hey, I'd rather just take 2 for 1. 2 6s in. 1 6 out, 6 times 3, 18. Or you can make it root 36. Same thing. What's the root of 36? 6. Either way, same thing, huh? 2 6s in. They're gone. 6 times 3, 18. No more root, huh? Because everything left here. So that's the first. We have 3 more to go. So that's just the first one. And now the root 6 goes to the 1. Root 6. He's done. So first to both. Root 6 times 1 is just root 6, right? Now, oops. That guy's done. Now it's this guy's turn. The negative, that negative's going with him. That's his baby. That negative, boom, boom. It's going to go to both there. So go ahead and take that one to both. Is that okay? Outsiders with outsiders, insiders with insiders. Outside numbers multiply outside numbers, and inside with inside. Like that. And now, there's a little more we can do there. What can we do? What needs to be further simplified? The 12, huh? Because the 12 has some pairs in it. It's a mess. And 2 for 1 we can do with the 12, huh? Yeah, the 12 is 3 times 4, and the 4 is 2 times 2. Yeah, so those 2 2s in, because there's nothing in the hook, so these are all square roots, aren't they? So the 2 2s inside will ship 1 2 outside. So the 2 2s inside ship 1 2 outside. So this becomes minus 18. What's left in the root?
3.
Just the 3, huh? And the other parts, you can't do anything with them. Like the root 6, that's just 2 times 3. So that's just it. I mean, none of those are like terms, huh? It's just, that's it. It's kind of weird. It's as far as we can go. There's nothing more to simplify that. Because all of them are different roots. This is a plain 18. This is a root 6. An 18 root 3, and then a root 2 kind of term. They're all different roots. Or plain numbers. They can't combine in any way. Adding, subtracting is always picky. It's got to be like roots, like letters. So we're done. Questions? All right. Okay, so try that one. First to both, second to both. Very first one, root 5x times root 5x. What's that going to be? Plain 5x, huh? Because it's 2 5x's in, 1 5x out. Yeah, because these are all square roots, aren't they? Nothing in the hook. They're all 2 roots. Exactly. So this guy goes to both. Yeah, root 5x, root 5x. Let's just make that plain 5x. Because it's 2 for 1 deal. That's 2 5x's inside roots is 1 5x outside of a root. Huh? Everybody see how that made a plain 5x? If you want to do it more slowly, you could. You know, if you wanted to say, well, wait a minute, shouldn't that be, 5x times 5x is 25x squared? Yeah, okay, you can do that. And then what is the square root of 25? 5. What's the square root of x squared? X. Yeah, it's just 5x in the end. It's quicker just to say root 5x, plain 5x. Because 2 whatever in is 1 out, right? 2 for 1 deal. Keep going. So we do the rest. Be minus root 30x. He's done. And then these guys multiply plus root 35x. And then Nathan's going to give positive root 42. And that's just it. None of that stuff can do anything, huh? That's just it. We're done. Now you might, if you're not sure, go ahead and check. I am sure. But if you're thinking, well, can't you break that down? Watch. No, there's no pairs in there. See, 5, 2, 3. There's not 2 of anything. I just know those numbers, so I know there's not. 35, 5, 7. There's not 2 of anything. 42, 6 times 7, which is 2, 3, 7. See, there's not 2 of anything. So they can't break down. That's just it. And they can't combine. They're all alike. Different roots, aren't they? So we're just done. Because adding, subtracting is picky. It's got to be exactly the same roots, same letters, or you can't add or subtract. And see why they didn't break down any further? When I broke them down, there wasn't 2 of anything. So there's no way I had do a 2 for 1. So they just stay as is. So this is the answer right here. All this stuff not needed. It turns out. We good? Here, for extra clarity, let me do this. Let me put these 3's in red. See those guys are 3 in the hook. The other 3 is just like a 3 in the front. This is a pretty tricky little problem. Honestly, I'm not going to put this on the test. I wouldn't worry. This is pretty picky. I'll show you how to do it real quick. I would forget about it after that. It's a little more. I picked the homework too quick. This is a little more tricky than is appropriate, I think. Anyway, so here we go. I'll show you what to do, but don't worry about it a lot. So here we go. So this one's going to go to all 3. So cube root of x, cube root of x. Well, inside stuff with inside stuff. So that'll be the cube root of x squared. Good so far? Insider with insider. That's just x times x squared, inside the cube root, minus. Now, 3 cube root of x times square root of x. Right? This guy just multiplied that guy. What's that going to do? Well, yeah, I'll show you in a minute. That's weird. Let's keep going. Plus 5 cube root x. He's done. He went to all 3. Now it's this guy's turn. Plus 1, that's easy. So plus cube root of x. Well, positive 1 is just going to be the same thing. Minus 3 root x plus 5. Okay. Now what? The main, well, yeah. Any like terms? Any terms that have the exact same letter and root pattern? These two. Everybody see that? Those two are the same. Those are like terms, aren't they? See that? Those are the only 2 that can add. All the rest are different in some way. Is everybody seeing that? Those 2 are like terms. So 5 cube roots of x and another cube root of x. Really, there's an invisible 1 in front there, huh? 5 cube roots of x and 1 more. This is 6 cube roots of x. These 2 guys make 6 cube roots of x. Is that good there? The rest just stay as they are. They're unlike terms. You can't do anything with them. Right? Like this guy's a square root. Everybody see that? That 3's in the front. So he has an invisible 2 in the hook. That's a different kind of root than that guy. So they're different. They're not like. Can't add them. This guy's different because he's got a 3 in the hook, but he's got x squared in there, so that's different. Now, what about this weird thing right here? What's that going to do? Well, really, it's pretty weird. I don't know. I never do it. Oh, it's going to be minus 2. Oh, I've said that already. Here we go. I'll do it. I don't know why they made this so crazy. This is a 1/3 power. I'm probably going to go a little fast here. I don't know if you remember that. Remember roots are fractional powers. Didn't we talk about that a little bit last time? A little bit, did we? This is more advanced. So that third, I'm not going to put this on the test. That third root's a 1/3 power. This is understood 2 in this hook, which means it's a half power. So if you want to multiply those, when you multiply those kind of things, you have to, what do? What is x squared times x cubed? You add the powers, right? X to the 5th, right? So in the same way, I've got to add those fractional powers. Oh, I see. Yeah, they're right. They are right. I see it happening now. Yeah, so if I want to add those powers, this, again, don't worry about this. This is too advanced. You got to add those powers, 1/3 and 1/2, and put it on a single x. That's what it means when you multiply two bases. Remember, we talked about that last time? Same bases, multiply, powers, add. Right? Now that's pretty hard. How do you add those fractions? Common denominator. So then you got to come in. This is just crazy. Then you got to come in with a common denominator. Top and bottom by 2, top and bottom by 3. And so that's x to the what? 2 6 plus 3 6, 5/6. That's pretty weird, huh? That's what it is. And then all the other stuff is just there. This is plus 6 cube root of x minus 3 root x plus 5. Actually, one other thing. Then they want you to swing that back around into a root. Remember? This guy swings around into the hook. So it'll actually become, when all is said and done, the 6th root of x to the 5th. I know, that's pretty advanced. So there it is. Forget about it. Just get in your notes for the homework. I'm not putting it on the test. I didn't notice it was that tricky when I picked it. It isn't. No, I can't remove it at this point. Yeah, once somebody's worked on it, it won't let me change the assignment because then it would be different for different people. So I can't. I'm sure somebody's looked at it, I'm sure.